So today we're going to do similar polygons. So for order for two polygons to be similar, they have to have corresponding angles congruent. So if you look at these triangles, this happens to be triangles, but it could be any shape. Notice that all the corresponding angles are the same. So I almost always check that first because that seems to be the easiest one. And then second, the corresponding sides have to be proportional. So this is the part that kind of takes a while. Basically what you do is you match up the sides and see if they reduce to the same fraction. So I usually start with the smallest one, so 12. So the smallest in this one goes with the smallest in the other one, so 12 over 16, and that reduces to 3/4. Then I go the medium over the medium. So where is that one? 15 over 20 is over here. And then finally 18 over 24. And notice that they all reduce to 3/4. That's called the scale factor or similarity ratio. The way you can think about that is the bigger the smaller triangle is 3/4 the size of the bigger triangle. That's what this similarity ratio or scale factor is about. Golden rectangle, golden ratio. I can go on rants about this, but this is like a really cool concept in math. This is like a very popular ratio. It's found in nature all the time. And it's basically, if you drew a square in a rectangle, the two rectangles, the big one and the little one, are similar. And their ratio is this, 1.618 to 1. That's the golden rectangle. It's thought to be pleasing to the eye. All right, so for this one, if the triangles are similar, list all pairs of congruent angles, write a proportion that relates the corresponding sides. So what I do is I kind of cheat and look at the letters. So I'll say like angle F is congruent to angle J, angle G is congruent to angle K, and then angle H is congruent to angle L. And then for the sides, I just make sure I have a system. Like I start with the small triangle and then do the big triangle. So all my numerators are the small triangle. So I'll do like GH to LK. And if you're not sure like which ones go together, just look at the order of the letters and that helps too. And then like FG with KJ, and then finally FH with LJ. So it takes a while, but it's not the worst thing. Okay, and these are all segments, so I almost forgot that. Okay, these ones, to decide if polygons are similar, the first thing you need to do is check the angles. So you have to say corresponding angles congruent. And if you look at all the markings, they are. And you know all the angles add up to 360, so it forces this fourth one to be the same too. Second is you do corresponding sides proportional. Oops. So what you do is like get a system down. I'm going to go left to right. And I'm going to like check some sides. So I'm going to do like smallest one, 3, and see if it equals the smallest one, 4. I don't have to reduce it. And then I'm going to try another one and see if they equal. So I'll do 4 and 8. And if you reduce them, they don't equal. So this is a no. Okay. This other one, try the angles. Yep, if you look at all the markings. And then the worst part is doing all the sides. So I'm going to do small to big. I just like to have a system. So I'm going to pair the smallest one with the smallest one and see if that equals the medium with the medium, and then see if that equals the largest with the largest. Okay, so as far as like simplifying these, for this first one, what I like to do is scale them out so they're like normal numbers. So if I multiply by 10, I get 92 over 115. If I multiply by 2, I get like nice numbers. I'll get 20 over 25. And then this one's like, I can just do my normal stuff like divide by 3, which is just like fancy ones when you're reducing. So that'd be 4/5. And if you reduce them all, they all do reduce to 4/5. So they are similar. So the answer is yes. And then the similarity statement, you write triangle. And I usually look at the letters. I started with the small one, so I'm going to go RST, and then you do a squiggle. Is similar to triangle NQP. And then my ratio is 4/5 or scale factor. Then I do the same thing with C. So you can pause and see if you can get it. Angles. Yep. Second, because you can do vertical angle theorem, you know. Second, do all the sides. So small with small. That was already reduced. And then I'm going to do medium with medium. And then see if that equals 5 with 20/3, which are kind of gross, you know. But you can do this little trick. Multiply by 3 for both of them. And you get 3/4. And then you get 12 over 16. And then this one you get 15 over 20. So if you know how to manipulate the fractions, it works. And you get 3/4 for all of them. So this is yes, scale factor 3/4. And I'm going to do the triangles. So I'll go BCD is similar to FCG. Oops, triangle FCG. Okay, then with these, you're just going to be solving. So they tell you they're similar. I usually do the angles first. So like, here's C. C is in the middle. It's going to pair with N, which of course I don't have, so that's fun. But I know that the angles are the same. So if H is 80, this is 80. So I'm just going to add y plus 12 plus 80 plus 38 equals 180. And if you solve that, you get 50. Then with the sides, their sides are proportional. So X is CP. CP is going to go with NV. So I'm going to go X over 12.8 equals, right? And then now I have to match up another side. So I'm going to match up 14.5 over 11.5. So notice I went left to right to keep like consistent on what I'm getting. And then you just cross multiply. Oops. And then you get 16. Okay. This one, change the numbers. This one should be 4, and then this should be 10. Okay, so for this one, you need to change the triangles or like redraw the triangles. So for this, I look at like, okay, here's this little guy, and then here's the big one, and I'll like redraw them. So for these sides, I've got 4 on the little guy, 7 down here. And then for the green one, it's this whole 1 is 10. And then this guy is kind of tricky. You have to take 10 without the x. And that's usually the hardest part. So then when I solve for x, oops, I'm going to go pink over green. And I'm going to go 10 minus x over 10 equals 4 over 7. And I'm going to cross multiply. So I get 7 times 10 minus x equals 40. Distribute. Subtract. Might freak out, but fractions are normal. So 37ths, because you get negative over negative. Okay, last one, golden rectangle. Really, what you just have to know is like, this is like famous. This is always like something you just have to know. So another way you can set these up is you could go like width over length. So you could just do width 1, length 1.618, and then you could do width 20 over length x. So that's another way. And then you can cross multiply 2.36 centimeters. And that'd be the answer. So work on the homework for the rest of